Thank you. Welcome. I know this is the last session before a lot of beer, so it's the first time I've ever presented in a bar. I've been in many bars in my life, but I've never presented a business presentation out of one, so this is a first for me. I'm sure it's a first for you. I wanted to share really some insights that Dell have had over the last 4 years from working with some of the world's largest and first cloud providers. Companies like Microsoft with their Azure, companies like Amazon with EC2 and S3, big social media companies like Facebook, and a lot of the gaming companies in China and other parts of the world. And what we think is interesting, and we'll take you through some of the learnings, is they're deploying thousands and thousands and thousands of server and storage devices in very, very demanding and unique environments. And I think for hosting companies or service providers, there's some lessons that we can bring to you through working with these companies and working together with them that might be able to help your businesses now and into the future. So I'm going to spend about half an hour just discussing, and then I'm going to open it up and we can have a Q&A, and if there's no questions, you can have beer faster, and if there's other questions, then we can tackle those. But before I begin, a couple of things. I don't want to give a sales presentation on Dell. This is not a Dell sales presentation. We've got machines in our booth, and got a lot of salespeople here. They can really talk to you about the specifics of servers. I really want to make it much more of a learnings that we've taken. But to get there, I do need to talk a little bit about the division that I run and why we have the ability to talk about these learnings. So if you'd let me spend a couple of minutes just talking about who we are in Data Center Solutions in Dell and what we do, and that will hopefully position this presentation a little better. So around 4 years ago, I'll tell a small story. Around four and a half years ago, we found at Dell that we were doing two things in some large accounts. The accounts I mentioned before, the Microsofts and the Amazons of this world. We were either losing business there, or we were winning business, but it was not profitable business for Dell. And like your companies, we like to make profit, and you like to make profit. We like to make profit by bringing solutions to our customers that's better than our competitors. And so in these accounts, in these big cloud accounts, we were just not being innovative enough on the server and storage side to really allow them to buy from us. And yet we found that they were buying in very large volumes, and we also found that a change was happening in the industry. So that we really, this was before the word cloud computing was in every piece of marketing collateral that every company sends out. And so this was before the word cloud became known for everything. We saw that there was a big change in the industry, and we wanted to really understand it. And so we formed a completely separate division in Dell, almost like a different company, where we have everything from our own engineers to our own support, our own salespeople, our own supply chain to go off and address these companies' needs. But the big difference is, and a little bit like your business is, your data center is your factory. You're not running a standard IT operations for a big company like Walmart or Ford or Disney. IT is the business. And so when we were working with these companies and we talked to them about their data centers, they saw their data centers as their factory. And every dollar of cost in their factory, whether it was a direct cost of buying equipment or running costs, made a significant impact to their bottom line, to the profitability of their businesses. And the enterprise servers and storage and applications didn't apply to them. Most of them wrote their own applications, and most servers and storage at the time were made very specifically for enterprise class applications where resiliency and redundancy was the key attribute. So RAS features were very, very important, and they added a huge amount of cost, not just to the acquisition price, but also to the operating cost of those data centers. If you have redundant power, right, and redundant power supplies, the power supplies are less efficient. If you have redundant fans, they cost more. If you have the ability to get 20 kilowatts to each rack, you want very, very dense solutions so that you're not wasting rack spaces in your very, very expensive data centers. And so that was the problem these customers faced. The way that we solved it at Dell, we realized that each one of those customers had very different needs, and so one product didn't fit all of them. And so we set up a business where we did custom servers and custom storage devices. We'll go in and work with Microsoft Azure, and we design a specific server just for them that just meets their absolute needs in their data center, and we'll sell them thousands. It's not available on Dell.com. No one else can buy it, but it met their specific needs. And that was the business model around the Data Center Solutions division. And so it was all about customizing to the TCO model of those specific accounts. And because they buy in thousands and thousands in rack after rack after rack, that business model made sense for Dell. And over the last 3 years, we've become, if we were a different company and not part of overall Dell, we would be the third largest x86 server vendor in the US. So, we've been pretty successful in that model, and the customers have been very successful as they've built out these very large clouds. And so these are just some of our case studies. So this is where the divisions come from. And so that's where our learnings come from. It's really working with the companies that really, generate about 15 to 20% of the world's server purchases and deploy those in multiple different locations worldwide. So just a little bit of history, not a sales pitch, but that's where we understand how to operate at scale and how to operate in these very, very large cloud or very large scaled out environments. Okay? So the first lesson we learned is that as you go off and deploy in the cloud, everybody's doing something different. Cloud doesn't mean one thing. Whether it's infrastructure as a service, or platform as a service, or SaaS, or large HPC, it's not one thing. And there's not one way to do it. And yet, total cost of ownership is critical. As you start to build out large-scale clouds, or scale the small cloud you're building today into the future, total cost of ownership should be what you're looking at versus acquisition cost. And I know you guys all know this, but measuring TCO has to be about your model, not someone else's model. And so what will happen is you'll get a lot of people telling you what the model is to go off and look at TCO. You'll have companies like Dell tell you what the models are. You'll have software companies tell you what the model is. You'll have power companies tell you what the model is. And a lot of that is to really sell their product or their unique value proposition. But here's what we found with the largest customers in the world is they built their own models, and they built it specific to their needs at a certain time, and they were very comprehensive about really understanding bringing every dollar of cost into the equation. Because acquisition cost in these very scaled out environments is still very important, but it's absolutely not the only cost you should really be looking at. Okay? So the lesson here is you build the model, get a lot of input from everybody. Get input from your infrastructure vendors, your hardware vendors, get input from your software partners, get input from people within your company, but make sure you put every dollar of cost in there. Because here's the thing, there's a lot of lies in TCO models, right? Everyone's pushing a certain angle and making sure that the TCO model works for their company and maybe not for you. All right? And the other thing that we found is, be very critical of your own model if you are going to produce a TCO, total cost of ownership model. Because we found some customers who built internal expertise over many years, and they felt it was very valuable for their business, but actually it was adding a huge amount of cost without a lot of benefit. We had customers building their own servers, and they thought that was a cheaper way of doing it. But when you added in all the cost of the people that they had to manage the supply chain, you added all the cost, the fact that they weren't getting big volume discounts, you added the cost when they couldn't manage the supply chain, and the overall cost was very, very high. So lesson number one, get a good TCO model. We can help with that, but make sure it meets your business needs and make sure you're developing it, but make sure also that you're very critical of your own teams and then they're not putting things in their model that are legacy and because you've built something up over time doesn't mean it's the right way to do it in the future. Okay? So we've got a lot of experience here. We've built models on behalf of our customers. We have a lot of experience, but as I said, we're not always right, and there's things our customers don't tell us, and there's things that they do But if you want help from Dell, we can show you some real-life examples we've done with customers as they built out these large clouds. We've got templates. We can give those to you. You can modify them yourselves for your own unique needs. Okay? The next one, does anyone know who this band is? It's an English band, so not a lot of people know. The second lesson is don't get caught up in the status quo. Status quo is don't do things the same in the future as you've done in the past, just because you're comfortable with it. Because the industry is moving at a huge pace. You know, the IT industry has always moved pretty fast. The last 3 years have been faster than anywhere else, whether that's in software development in the cloud, or whether it's in speed of technology and in components, such as processor, moving from single cores to multi-cores. You know, John Free from AMD was talking this morning about 12, 16 cores in a single processor, whereas just a couple of years ago it was, 2 and 4. Well, everything's changing. And so what we found was the companies we worked with who settled for the things they did in the past were the ones that really got left behind, and it affected the bottom line of their business. You know, by not moving to new models of infrastructure, taking the old servers like this one over here, which is a standard, one socket, one motherboard, and one U in the data center. They just weren't competitive in the cloud business because the infrastructure is a huge part of that overall cost in the cloud. And so our second lesson is, you've got to keep up, be at the bleeding edge, the cutting edge of all the innovation that's happening in the industry, not just from Dell, but from our competitors and from everybody else. You've got to look at some of these new designs and these new ways of deploying raw compute power or raw storage. And don't get caught up at the old way of doing it, whether it's fiber channel or these old, one socket, one use systems. That's going to really, really affect your bottom line as you go and build cloud infrastructures. And there's some great examples out there in the market. Of course, these are great Dell examples. But, everything from looking at microservers that Intel announced over the last couple of days, through to modular data centers. There's a huge more amount of form factors out there. There's a lot more choice, and if you optimize those, you really start to see some significant total cost of ownership benefits in terms of infrastructure costs. You can pack so much more technology into a smaller footprint now, and the power and cooling is a huge part of that. Just to give you one example, when we first started 4 years ago with some of these customers, they were building data centers with raised floors. The typical PUE, the power utilization efficiency of those data centers, best of breed was maybe 1.6, maybe 1.4. So for every dollar or euro they spent on powering up their cloud, they were spending $0.50 or €0.50 on cooling it. We've now deployed solutions for customers in these cloud environments where their PUE is down at 1.03. So for every dollar they spend, they're spending 3 cents on cooling that environment. Well, you add that over, 4 or 5 years, over 10,000 servers, 20,000 servers, that's a huge difference between profit and loss in the cloud. So whilst everyone isn't at this scale, the clear message here is you've got to keep looking at all these new form factors. The industry's changing a lot. We know that there's a lot of pain sometimes that goes with moving from one form factor to another in terms of how you operate that in your data center. But again, if you don't do it, your competition is, and they're going to get a much better underlying cost base, and you're going to become unprofitable pretty quick. Okay? Again, I said this wasn't a sales pitch, but I'm using this as an example, and I'll use a Dell example because I have a Dell badge. But what it means to your top line, and this is just an example. We announced a server from World Hosting Day yesterday. In fact, it's the first time Dell has ever launched a server globally from outside of the US, and that was launched yesterday here in Germany. But it's our microserver. It's a 12 servers, 12 one-socket servers in a 3U form factor. So we did some basic analysis that said, okay, theoretically, if you have enough power, you can get 144 servers in a 42U rack. If you use the old form factor of one-socket servers, you get 40. And so if you're measuring the amount of revenue per rack or square foot of your data center, we did some analysis here, and you can get almost €1 million per year more if you're selling one socket dedicated servers by using these new form factors than you can using old form factors. So that's on the top line level. Just sticking more compute and storage in an individual rack will allow you to make more top line revenue. Now here's the other thing. If you look at energy bills, you look at the efficiencies that some of these new form factors are driving, shared infrastructure, sharing fans, sharing power supplies, then the overall energy savings are going to be massive as well. So moving to those new form factors doesn't just help your top line, but it really will reduce your costs, especially as you scale. If you've got maybe one rack, then the percentage of difference isn't that much, but as you build out and scale, which I'm sure a lot of you are thinking of doing as you build your businesses, these cost savings start to add up, or if you're not making these savings, then the cost of difference that you have with your competitors really adds up. And you're going to have to make up that in reduced profit, or you're going to have to make that up somewhere else in terms of how you make your profit. Okay, this is another example in the hyperscale space. This is based on deploying 1,000 servers. We did a lot of work to reduce power. We started up here with the server being around 235 watts per motherboard. We optimized that over the deployment, and we took that power down from 235 to 170 watts per motherboard in the shared infrastructure solution. And you can see that there's savings over 1,000 units. And again, this is big. PUE is pretty bad still, but there was €500,000 of saving and 2.1 megawatts of power over 3 TCO. Sure.
Sorry, just a short question. What time frame you are talking about?
This is 3 years.
3 years.
Yeah.
So it took you 3 years to get the power down?
No, sorry. This was in our custom business. So this was here when we first discussed with the customer. We had a proof of concept server, and then we deployed at 170. It was about 2 months.
Okay.
It's about 2 months in that customer of doing the optimization and the tuning of that product. Right? We've now taken these products that were custom, and we're selling these in the Dell PowerEdge C product line. So we now have taken these from the custom servers I talked about, and they're now available to everybody. Right? My point here is, if you move from here to here through that optimization and through buying optimized servers in these new form factors, when you start getting into deploying of thousands of machines, the value proposition is really high.
If you have questions, feel free to raise your hand. We do have a microphone for you so that we all can hear you.
Okay. The other thing is, it's not just about the hardware, right? So we also found that services are often developed for enterprise class applications and normal customers, not so much the hosting market or large scaled out markets. So when you're challenging your suppliers on the hardware and really going after some innovation and new form factors on the hardware, the same questions have to apply to services. So rather than servicing or paying for service on every individual node, we're looking at spares parts on site, rack and stack integration. Often the really big cloud accounts, they don't want to have working capital on their factory floor that's not adding business value, and I'll talk about this in the next lesson. But same with services. If you're over-specifying the services you need from your suppliers, it's exactly the same thing. It's just a waste of money. Okay, so lesson number 3 is, the most expensive server or storage node is the one that isn't used, or it's the one you really need and isn't in your environment. And so what we found was, when we first set up the Data Center Solutions division and we were providing all of this customization on technology, we thought that winning these accounts was all about technology. It's all about having a better server, a faster server, a more power efficient server. But what we soon found out was that when you're deploying at hyperscale, to the world's largest cloud providers, they have very demanding needs on supply chain. You know, they want 10, 15,000 servers delivered in 4 weeks or 3 weeks to 5 locations worldwide. They wanted us to show up with the servers fully racked and stacked, ready to go, cabled. They wanted to show up between 5 and 6 in the morning at their data centers. They wanted us to roll the racks in, plug in power, plug in top of rack switch, and they wanted that server, that rack of servers, to be adding revenue to their bottom line in 5 hours. And we call it Arrive and Live in 5. So we've built a lot of expertise in the company to be able to provide just-in-time IT. To go in and rack and stack and cable, you know, that's something that you should think about. Is that your core competency? Is that something you want to be doing? Or is that something that you'd want someone else to do so that when your equipment arrives, it's really adding value as quickly as possible? It's not sitting on your factory floor, your factory in your data center, gathering dust and aging for 6 to 9 weeks before you have someone to get around to deploying that infrastructure. So, you know, it might seem very, might seem a very natural thing for you to do, that you know these lessons, but you know, what we found was that a lot of even the largest companies were taking servers at the time and then waiting for 3 or 4 weeks before they got around to actually cabling them up themselves or racking them or stacking them and getting them adding to their bottom line. And for them, this market moves so fast they couldn't afford to do that. The other one is, you know, if they didn't have the servers there, and their business units, whether they were doing search or whether they were doing, you know, serving up VMs, if they had, you know, extra demand and there wasn't enough infrastructure there, then they were losing business every day. So, you know, a couple of learnings is, you know, we talk about Arrive and Live in 5. It's really about just-in-time IT. You know, making sure that you're working with your suppliers in forecasting your needs, and I know forecasting is incredibly hard. I'm responsible for forecasting in my part of the business. It's one of the hardest parts of my role. I'm sure you guys are the same. But you know, look at that just in time. Make sure that you've got the right processes on your side as well, and you're working with your suppliers on forecasting, right? Because there is a cost to the business as well. And so we now have a lot of our customers and the ultra big ones really understanding that if they miss forecast, that gets put into their TCO model that I talked about at the beginning. If you can't have capacity there waiting to go when you need it, that has a cost. If you have extra capacity there, you know, before you need it, that adds cost to your business as well. And so if you're managing your own supply chains, if you're managing too many partners, if you're managing too few partners, you know, that all impacts on that metric. Okay, lesson number 4 is bad code. If you had people writing bad cloud code, it would also massively impact the cost of doing business. And from our perspective, here's a few reasons why. If you write code that requires redundancy at the hardware level, you're going to have huge amount of added cost in your hardware infrastructure to cope with single node failures. If you're architecting a cloud solution, whatever it is, whether it's SaaS or PaaS or IaaS, and you're developing that code where a single node or a certain failure domain will bring down your service, you're going to have to make sure that you're over-specifying and that you're provisioning on the hardware layer. So we have a lot of the big cloud customers, they never have redundant power. They don't have redundant fans. Some of our customers don't put any fans in their systems anymore because they're working in these big modular data centers. But you know, the thing that usually drives over-specified RAS features in a server is because the application isn't aware and doesn't scale properly and doesn't scale over multiple nodes to give it redundancy at the SLA level, right? The second thing is that, you know, if the code isn't optimized, then there's more and more servers needed. So if you think about Facebook, Facebook's one of our customers, and you think about the people that write the Facebook code, you know, they're constantly working with their hardware, their internal hardware teams and us to figure out how can I make the code better? You know, how can I make the code scale more? How can I make the code lighter? And then I can have less servers to do a particular job. And so, you know, the thing we've learned is that from a software side, if you give a software developer, you say, hey, you've got this 2-socket, you know, with 48 gigs of RAM and X amount of hard drives, they will write code to, you know, to take advantage of as much as they can. You know, and so you know, you bring them down and give them less, and they start to get much more creative and really kind of try and write their code to be more efficient. But here's the other thing is, and you've seen this already with Rackspace and OpenStack, you know, not everyone wants to write their own base infrastructure as a service code, or, you know, there's so many companies out there right now offering some really great base products. You know, really think hard about what you're going to write and what adds value to you and what's already out there that you can get commercially, and go and figure out where you write code if you are going to write code, and where you go off and buy it. Right? And so we're working with some of these partners. There's a whole bunch of partners we're not working with. But there's enough cloud stacks around right now that you should really understand what business you're in and figure out what you want to write and what you don't want to write. Okay, and then my last lesson, I'm a marketing guy, so I'm sure some of you are as well, is here's what we found, is don't just talk about cloud. It doesn't mean anything anymore. You know, I walked through the last couple of days, and I know it's a great word, we all use it, we have to use it in some way. But what we found is that unless you're really talking to your customers about their true pain points and aligning your products and your services and your capabilities with those true pain points, there's going to be a diminishing return on the use of the word cloud real soon. And so what we found as we've developed our business, 3 years ago, we were talking our division as just a cloud division. Well, that's not what we talk about now. We talk about helping customers deploy infrastructure at the right total cost of ownership so they can build cloud operations themselves. You've got to be really clear where you play and where you don't play. Customers are becoming massively disillusioned with just this word cloud. So really go in and define, you know, exactly what your product is. We did some analysis, and we looked here. This is Web 2.0, Google hits and searches. This is here Britney Spears. And even though cloud, if you do a search word on Google, cloud is much more popular than Britney Spears, you still don't have to use it for every piece of marketing collateral that you go off and do. All right. And so, you know, there's a big lesson there for your marketing teams. Really go and speak to your customers about what true pain points you're solving, versus use the word cloud and just overuse it and confuse the industry even more. Okay, so I'll quickly summarize, and then I'll open up to any questions. Our first lesson is, look, you've got to really go off and build a TCO model that works for you, but make sure it's comprehensive, and make sure that you bring everything into it. Look inside your company and find out if you're doing things that you've always done, and are they contributing to higher costs? Are there better ways of doing that? Don't ever trust one company to build your TCO model for you, even if that company is Dell. We'll have our view. You know, we don't have all the answers. We'll have some of the answers. We'll have a lot of experience where we've built models for people, or we've built parts of the model and then they've integrated it into their model. But if you don't have a good view of your total cost of ownership, you'll get surprised, because everybody here is competing for you know, the same sort of customers, and it's a very competitive market, and every dollar, every cent or every euro really kind of adds or changes the bottom line. In fact, the guy who runs, the general manager who runs Microsoft's cloud, the Azure cloud, is a guy called Doug Hauger. And you know, when we started to work with Microsoft and Doug, he said to us in our first meeting, hey, the cloud's about cents versus dollars in TCO. Profit and loss is made in the cent, you know. Machine time per hour is cents. It's not a dollar business anymore. And so I want to look at every cent of cost that I have in my environment. Second is I talked about the status quo. There's a huge amount of innovation that's happening in the industry. You know, Dell are innovating, HP are innovating, we're all trying to innovate on your behalf. You know, help us do that by talking to us more. But if you don't keep up with the pace of innovation, whether it's at the hardware layer or the software layer, you are going to get left behind. Third lesson is, you know, this whole thing about forecasting and making sure that you've got infrastructure when you need it. Don't have stuff sitting there too long. You know, this might be a lot more for the really big accounts, but there's definitely some lessons to be learned in the fact that if the data center is your factory, treat it like a factory. Factory people, if you're going to speak to true factory managers, you never have, you know, inventory on their shop floor. You know, it's a huge cost to the business. If they're the hosting world, the service provider world shouldn't be any different. I talked about bad code, you know, really go off and figure out, are you writing code for the new world, for the revolutionary new applications that are coming out that are going to scale over multiple nodes, or you've been way too conservative and are you building in, you know, too much hardware redundancy and reliance on infrastructure to keep SLAs up versus doing that in your software code. And then the last is, you know, be careful what you advertise. You've really got to make it real for your customers. Don't overplay and use the word cloud too much. You know, even Facebook, you know, who's constantly referred to as a cloud, if you go and speak to their marketing department, they're like, we're not a cloud at all. We're a social media company. You know, if you go and look at other, you know, enlightened software as a service providers, they're talking about, you know, software as a service versus just cloud. So hopefully that was informative and useful. If there's any questions, then raise them, and hopefully we can all go and have a beer.
Thank you, Andy Rhodes. In particular, I like what you said about the cloud, because when I arrived at this lovely outskirts of the Schwarzwald here in southern Germany, and I had my first conversation with one of the many experts walking around here, I think it took him 12 seconds until he started using the word cloud. You might want to keep the microphone, because when we start having a discussion, we do want to make sure to hear you.
Got it.
Do you have questions? Is there anything you want to know or you want to comment on? Stefan. Wait a second, I'll be right with you. So, what's your question?
First of all, thanks for this great presentation. I'd like to come back to the power. You brought down it from 250 to 170. What's your trend or your forecast for the future? So what do you think if you say, okay, this is 100 now, where we are in, let's say, 3 years from now? Because we all know that the data is growing.
Sure.
And associated with this question, I have a second question. What is Dell's strategy regarding tape backup or using tape in a data center?
Okay, great. Let me answer your first question. A lot of the power. There's two ways to reduce power. You know, the first is the technology ingredients that are in the servers. So what Intel are doing with their roadmap and what AMD is doing with their roadmap. We've even done a lot of work in Dell with new processor vendors like VIA and ARM. So I think there's going to be an increasing trend of microservers and trying to reduce the footprint on microservers. The other trend is on looking at multi-core and going the other way, and so getting more and more VMs on bigger, fatter servers. So that's really dividing into two. Some customers are saying, I'm going to go away from virtualization in my cloud environments and use physicalization, and then I'm going to go to some really small, very right-sized processors and put the right application workloads on those processors. And so you'll start to see more of Intel's roadmap go down to that low end. Same with AMD, same with VIA, same with companies like Marvell and ARM. And then on the other side, you'll also see a lot of companies really try and drive up big machines so that you can really virtualize lots of VMs on one machine. And then you get a lot of power savings because you share infrastructure again. And then on the other side, what we see is that companies are starting, at least the large vendors, they're starting to see the data center and the servers and storage in the data center as one closed-loop system. So, when I refer to the example we had, and hopefully this will be a public case study soon, of driving a customer to a power utilization efficiency of 1.03, the reason that we could do that was we designed the modular containerized data centers and the servers together. And so we took all the fans out of the server, and that allowed us to really cut down on power of each individual node. Where it's going to be in 3 years, I don't know. We're still projecting that out. But the trend of either power been the same, but you're able to get many, many more virtual machines on each node will definitely increase. And then there's going to be I think a big trend still for physicalization, where you have smaller servers with right-sized workloads on them. Tape backup. I can't speak for the whole Dell strategy because I don't work in the tape backup division. We haven't seen that in these big cloud environments. They're really using a lot of SSD for fast response where they need to get to storage or even flash. And then on the back end, when they're doing big file stores, they're using cheap SATA drives and replicating the data many times. Haven't seen in the large cloud environments any tape usage. Roy's one of my colleagues. Have you?
No. Would you like to wait for just a second so that we can all hear you? Thank you.
The other thing on the tape side, I think Andy is right. I mean, what we're seeing is customers replicating data more and not really looking at doing tape backup, right? Or doing large backups. Now, a lot of the data is not as critical in some of the environments that we're talking about, right? In terms of data, it's not something that, it's not like your financial data or whatnot. So we're not seeing there. The other item I will add to your first question of where do we see power going in the next 3 years? I think that what we're seeing, and I think the microservers is a function of it, is that people are going to be analyzing and right-sizing hardware and infrastructure for the particular workloads. I think there wasn't as much knowledge in the industry 3 years ago when we were looking at very general purpose servers. We're really trying to optimize the component side. Now as some of the workloads are getting larger and larger, they're actually justifying getting custom hardware for those workloads. So that's where new technology can actually start becoming things like ARM can start becoming disruptive because they could potentially run workloads more efficiently than traditional servers are today.
Does this answer your question, Stefan? Great. So then, let me ask you something. And do TCO models differ by geography? Talk of, let's say the US versus Europe.
Yeah, I think that's a great question. So TCO models differ by geography. They differ by customer, by workload, by what business you're in, by how old your data center is. Is it new? Is it? But they definitely differ by geography, and mainly because the cost of power is different across the world, and the availability of power is different across the world. So a lot of the customers I talked about now, they're set up in Quincy and Washington in the US. They get a lot of cold outside air, and they're near big hydroelectric dams, and they're paying 3 cents a kilowatt hour, right? 3 US cents a kilowatt hour for power. Massively changes their economics. And they build brand new data centers that cost $500 million, and so they can get 30 kilowatts to each rack, and they can cool that, right? So that has a huge impact. You go to China, and China is completely different. China's a different market because it's not really the cost of power; it's the availability of power. All of the co-location companies is really run by the Chinese government, and so they're limiting racks to maybe 2 kilowatts a rack, and so that really changes the economics of the TCO. And then even in parts of Europe, I'm sure here in Germany we're hearing that power is expensive at 25 US cents, maybe 17 euro cents a kilowatt hour, and maybe parts of France it's cheaper. So the local energy power plays a huge part in that. Cost of building data centers, plays a huge part in that as well. So geographies do really matter. What we try and do, and again it comes to my first point, is don't ever let someone come and tell you what the TCO is until they've asked all the right questions, because those are things that you've got to really understand.
Do you have any further questions? I can sense somehow that you all want to have a beer, right?
I definitely do.
You definitely want to have a beer. Well, but I'm sure that you're also open for further questions.
Absolutely, yeah.
People can chase after you at the party, right?
They can. Well, I'm leaving in about an hour, but I'll come and have a beer, and then there's a lot of my colleagues here from Dell. They'll be on the booth tomorrow as well, so come by. I know a lot of you have already come by and stopped by, but we'll be happy to answer any more
But to
questions.
make it clear, you're leaving now and you'll be back.
I'll be back at the booth for an hour, and then I'm leaving for Frankfurt. But a lot of the colleagues will be around, so
Okay.
I'll be down in the beer fest.
I was
for an
just
hour.
about to say that the beer party will not be without Dell people. That's what we want to know.
The beer party will definitely be with Dell people.
Okay, great. So let me ask you a final question. If if Dell apparently knows it all, when will Dell offer the cloud? When we can expect the cloud from Dell?
Yeah, we get asked a lot of questions of is Dell going to create our own clouds? Are we going to compete with the likes of Amazon and Microsoft? And the answer is, we already have a clouds at Dell. We bought Perot Systems a while back, and so we are offering some of our customers cloud-like services today. It's really in very, very niche space where we're writing their applications in US healthcare and some education customers that have asked us to really go off and write their applications. So we have that capability now in Dell. And then we've written their app and we're managing their apps, and they've asked us to go off and host them for them, because we're managing the end-to-end lifecycle of that application. Then we've built a cloud to go off, an infrastructure as a service cloud and a platform as a service cloud to go off and offer that capability. So all of the things that I talked about today are things that we in the Data Center Solutions division are working with our own IT department, our own service offerings on. So we do have some learnings, and we're happy to share some of the specifics if you want to talk about that.
Great. Thanks for being here, Andy. Thank you so much for sharing your expertise and giving us such a really very interesting insight of what you're doing.
Great, welcome. Thank you. Thank you for the time.
Thank you for your attention, and I guess we're gonna go all together to the party now, right?
Perfect.
So thanks for coming. We'll be back